Hi, this is Mrs. Jackson. This is Chapter 2, Section 4, Part 3. We're going to start to look at solving for complex solutions of quadratic equations. And in order to do that, we're going to need to know some basic arithmetic with complex numbers. So in this video, we're going to take a look at addition, subtraction, multiplication, and division. Okay, so starting out with the simple, looking at addition and subtraction. To add and subtract complex numbers, we would combine like terms. And by that, I would mean combine the real parts. So I'll say the real terms and the imaginary terms. Sorry, I didn't leave enough room here. So you're going to combine the like terms together. For example, here I've got an expression, negative 2 plus 5i plus 7i minus 8. Now, one thing to note is these parentheses are not doing anything for us. We're just looking at two complex numbers. That's why there's parentheses around them. But they certainly don't indicate multiplication in any way. So we're going to combine our real terms together, and we're going to combine our imaginary terms together. So we've got negative 2, negative 8, plus 5i, plus 7i. That's going to give us negative 10, plus 12i. And I do want you to get in the mode of putting your real term first, followed by your imaginary term. Now in the second example, we're finding the difference. We're subtracting, and in this case, the parentheses do matter. So this is effectively like a negative 1 in front of a set of parentheses. So that's going to have an effect of changing their sign. So we've got 10 minus 4i minus 6, and then we're subtracting a negative I, which would be adding an I. So we've got 10 minus 6 is 4. Negative 4i plus 1i is negative 3i. All right, let's talk about multiplication of complex numbers. One thing to note is in the very first video of this series, we talked about the square of I. So I squared equals a real number. I squared equals negative 1. So it's important to remember this property of imaginary numbers because we're going to use it when we start to get into multiplication. Okay, so let's first take a look at negative 2i multiplying the difference of 5 and negative 3i. So we are going to use our distributive property, and the negative 2i is going to get distributed to both terms. So I've got negative 10i, and negative 2i times a negative 3i is going to be a positive 6i squared. I times I would be I squared. And now we're going to substitute that negative 1 in. So I've got negative 10i plus 6, and that I squared, remember, is negative 1. So when we simplify this, we have negative 10i minus 6. And then just use your commutative property of addition and put this in the real form first, followed by the imaginary. Okay, moving on. Now let's look at two binomials multiplying each other. So everything's got to distribute, the 4 and the 3i. So starting out with the 4, we end up with negative 8. And 4 times a negative 5i is negative 20i. 3i times a negative 2 is negative 6i. And positive 3i times a negative 5i is negative 15i squared. Okay, so I've got negative 8. I'm going to combine these two terms. I've got negative 26i. And then this negative 15i squared is negative 15 times a negative 1. It's real. So I've got negative 8 negative 26i. This turns into positive 15. Combine negative 8 and positive 15 are real parts together, and I got 7 minus 26i. Okay, last example on this page. We've got two binomials again multiplying each other, and notice the first term, the real term, they're identical, and the imaginary terms are opposites. So I've got 2 plus 3i times 2 minus 3i. And something interesting happens when we have binomials that look like this. So let's observe. 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times a positive 2 is a positive 6i. And negative 3i times a positive 3i is negative 9i squared. So you can see right away the resulting opposites here, the negative 6i plus 6i, they're going to cancel or reduce to 0. And then I have left the 4 minus 9, and I squared is a negative 1. So I have 4 plus 9, which is 13. So this is a very important concept. You use it in the electronics industry quite a bit, and we're leading to a new vocab term here. The result here, let me first talk about the result. It's real. We have no imaginary parts left in this answer. So that's one important observation. These terms here, where we have the same real term and opposite imaginary terms, these are called complex conjugates. Complex conjugates. And we're going to use them quite a bit to do some division problems and also simplify some of these multiplication problems. So complex conjugates, we have equal real parts, and we have opposite, always opposite in math means sign, opposite imaginary parts. And what is the result of their product? The result of their product is real. In this case, in our example, it's the number 13. So the imaginary part will go away when we multiply complex conjugates. So this is going to be important as we move into division. So when we divide by a complex number, remember to, and so these are going to be the steps that we do, you're going to make that divisor is what's on the bottom, make that divisor real by multiplying it by its complex conjugate. Okay, so let's take a look at an example here. We have the number 8 being divided by a complex number. The complex number is 1 plus I. The analogy I would give you is, remember, we never leave irrational numbers like the square root of 2 in the denominator of a fraction. Kind of the same thing here. When we have a complex number in the denominator, we want to make that real. We don't want that complex number in the denominator or the divisor. So the way we're going to deal with that is we're going to multiply it by its complex conjugate. The complex conjugate has the equal real parts with opposite imaginary parts. Now, if I multiply the bottom of that fraction by 1 minus I have to multiply the top by 1 minus I as well. Essentially, I'm going to multiply it by the number 1. Anything divided by itself reduces to the number 1. So I'm not changing this in any way. I'm just, what I say is rearranging the furniture. The same expression I would use when we rationalize the denominator. So when I do that, I've got on the top 8 times 1 minus I, and on the bottom I have 1 plus I times 1 minus I. And we know the product of complex conjugates is real. So on the top, I have 8 minus 8i. On the bottom, I have 1 times 1 is 1. 1 times negative I is negative I. Positive I times positive 1 is a positive I. And I times a negative I is negative I squared. So right away, you see we get our cancellation, and I have on the top 8 minus 8i. On the bottom, I have 1 minus I squared. I squared is a negative 1. So I have 1 plus 1, or 2. Now, both of these terms in the numerator are evenly divisible by 2. So I can continue to simplify this. 8 divided by 2 is 4. And negative 8i divided by 2 is negative 4i. So this ratio here, 8 divided by 1 plus I, is reduced or simplified to 4 minus 4i. All right, let's take a look at something a little bit more complex here. So I've got 4 minus 3i divided by negative 1 plus 2i. When we have that complex number in the denominator, we're going to multiply that denominator, as well as the numerator, by the complex conjugate. The real part is the same, and the imaginary part is opposite. I'm going to pause right here for a second. The consistent mistake that I see students do here is that they would multiply it by positive 1 minus 2i. That will not give you a real number. So it's important that you really understand what a complex conjugate is. Same real part, equal real part, opposite imaginary. So if we multiply the denominator by negative 1 minus 2i, we have to do that on the numerator. So on the numerator, sorry, I want to make that blue. So on the numerator, we have 4 minus 3i times negative 1 minus 2i. And on the denominator, we have negative 1 plus 2i times negative 1 minus 2i. So I'm going to start my distribution here. In the numerator, I have 4 times a negative 1 is negative 4. 4 times a negative 2i is negative 8i. Negative 3i times a negative 1 is positive 3i. And negative 3i times a negative 2i is a positive 6i squared. And on the denominator, I have negative 1 times negative 1 is a positive 1. Negative 1 times a negative 2i is a positive 2i. Positive 2i times a negative 1 is a negative 2i. And positive 2i times a negative 2i is a negative 4i squared. So we can kind of simplify things up. These are canceling. And in the numerator, I have negative 4 plus 6i squared. I squared is a negative 1. So that's negative 4 minus 6 is a negative 10. Negative 8i plus 3i is a minus 5i. And the denominator, we have 1 minus 4i squared. I squared is a negative 1. So that's 1 plus 4, which is 5. And we can simplify. Both of these terms up here in the numerator are evenly divisible by 5. So I've got negative 10 divided by 5 is a negative 2. Negative 5i divided by 5 is a negative I. So this whole thing reduces to negative 2 minus I. So in this video, we took a look at some basic arithmetic using complex numbers. We're going to be using this skill and building on the skill when we start to solve quadratic equations that have complex solutions. Okay, thanks for listening. Hope this helps.